Chris already mentioned before. So in this workshop, we're going to see an example of a smart contract written in Rust for an NFT. Okay. Well, first of all, my name is Jose Franco. I'm also an integration engineer at Off-Chain Labs. Here are my Twitter and Telegram handles in case you want to contact me. I don't write a lot on Twitter, but you can contact me there if you want. Okay. So I'm going to try to be brief on this workshop, but still I need to touch on several things. So in this case, we're going to talk about NFTs first. I'm assuming that some of you might know what an NFT is, some of you might not. So we are going to briefly explain what it is. We're going to explain, sorry, what is the ERC 721 standard that defines how to build NFTs. And then we are going to talk about how to translate that interface, that standard, into a Rust program, okay? So let's start with the basics. What is an NFT? So an NFT is it stands for non-fungible token. So they are different than the fungible tokens. Those are the ERC20 tokens. In that for ERC20, each token is not different from the others. It's the same one. Like for example, if you have one USDC, which is a fungible token, it's the same as having another USDC. For non-fungible tokens, that's different, and each token is different from each other. Okay. So as examples, we have, for example, if this is used for art and collectibles. In this slide, we have some images of the Azuki collection. So this collection is an NFT, and each one of the images is a different token. So as you see, having the first token is different than the second one. And even it can have different properties, different values. Yeah, they are completely different from each other. Okay. So NFTs are also used for gaming assets. So, for example, if you want to have a smart contract that has all the weapons that are used in a game, for example, each token might represent a different weapon with different attributes, with different properties, etc. And it's also used for financial instruments. That's another example. So, if you invest in a pool, you invest a pair of tokens in a pool, you can receive an NFT that identifies that investment, and actually that allows you to be like more liquid because you can actually sell your operation to, I don't know, to a third party, to another person. So NFTs, as I said before, follow the ERC 721 standard, and that's what we are going to see to build our smart contract. Okay, but yeah, well, I'm going to touch briefly into these properties of an NFT. So no two tokens are the same. So there is some uniqueness going on in that in NFTs. Also, tokens can be divided into smaller parts. That means that you can't have like 0.1 NFT. You have to have at least one. And portability, we mentioned before, you can transfer that easily to other parties. And authenticity means that there is always track of who is the current owner and who has been an owner of a specific token or a specific NFT in the blockchain. Okay, that's actually a property of the blockchain more than the NFT, but in this context, it is very important. So the ERC 721 standard. This is like the guide to write our smart contract. And this is what we are going to use, right? So this standard defines an interface for APIs of NFT smart contracts. What does this mean? This means that it tells us what functions does our NFT have to be able to be properly like used in the blockchain, right? So it actually attempts to build a standardized way of operating with NFTs without having to know the implementation details. So you don't, as a user, you don't really need to know what is inside a function to be able to use it. I mean, you should know from a security point of view, but as a user, just use it. You don't know like how it is implemented. You don't know actually what language it is implemented in. You just need to know the signature of the function to be able to call it. And that's what the standard gives us. It doesn't give us implementation details, sorry. It just gives us function signature. Okay, we're going to see that now. This is an example, well, not an example. This is part of the actual ERC 721 standard. If you see down here, we have several function signatures, and this is what the standard tells us. So if we want our token to be transferred in a standard way, we have to implement a function called transfer from that takes these arguments and, well, in this case, doesn't return anything. But for example, the balance of function takes one argument, the owner, and returns a uint256. So the standard does this with all the functions that the NFT should have as a minimum. You can have more functions if you want, but as a minimum to be standard, you should have these functions with these signatures, okay? And the standard also gives us signatures for the events that this smart contract, this NFT has to meet, okay? We're going to talk about events soon, and you'll understand why they are important. Well, you have the full specification here if you want. Don't worry about copying any of the links because I'm going to share these. Well, I'm going to share later a QR code that goes to a repository of code that we're going to see today, and that has all the resources that we're going to talk about today, including this presentation. I'm also going to share these in the FOSSASIA specific Telegram group. I think there is a banner in the workshop room with that QR code that you can scan as well if you want. So yeah, I'll share that later in the group. My colleague Chris already explained this, but these are just some resources to start with Stylus. There is a quick start in the public documentation of Arbitrum that goes through how to set up your environment. Chris already explained all this, so I'm not going to get into the details about this. There's also this Stylus example portal that gives a lot of examples of how to use graphs to write your smart contract and do several specific things for Stylus, like for example, how do you emit a log in your smart contract, and many other things. And the awesome Stylus repository that has a lot of examples, a lot of resources to keep exploring Stylus and more examples. This is also, well, something that Chris already explained, how to create a new Stylus project, so I'm not going to get into that. Just the Cargo Stylus tool. It is also explained in the public documentation, so in case you missed the previous workshop, it is explained there. All right, so let's explain a bit what do we need to keep in mind when creating our Stylus smart contract. So I like to think about 4 different elements that I need to keep in mind. I need to think about when adding functionalities to my smart contract. And this is actually the elements that we are going to touch on the different functions that we want to add for our NFT, all right? So the first one is the storage layout. That means what information we need to store in the smart contract and what type of information that is, okay? Then we need the implementation of the methods, obviously what method we need to have and how they are implemented. We need to know also the events that we are going to emit, and we have to define them in our smart contract and emit them in the methods that we are going to emit them. And we need to keep also in mind error handling, okay? We're going to see all of these with the examples that we're going to see today, except error handling. I'm not going to cover that, but there is plenty in the example repository that I'm going to share. There are many examples as well in the documentation. So yeah, that's on the next one. So a storage layout, first thing. Following up on what Chris explained already. With the first thing that I like to think about is what variables do I need to store to be able to give the smart contract the functionality that I want to give it, and also what variables we need and where do we store them, right? Where do we put them in the code, right? So we have these macros, solidity storage and sol storage, that allows us to do that, right? So we just use that macro. We can use solidity storage if we want to write this struct in using Rust syntax, or we can use sol storage if we want to use solidity syntax. So in this case, for simplicity, we are going to use solidity. And inside the struct that we are going to create, we are just going to add whatever storage variable that we need, right? So in this case, it's a mapping of token IDs to owners. If you don't know what a mapping is, think of it as similar to an array. There are arrays as well in Solidity, but you can picture it like an array where the u into 56 is the key of the array and address is the value. So we are saying for each token ID, who is the owner, what is the address of the owner, okay? And we are storing that in the owner's variable. So next is the implementation of methods. As Chris already explained, we use this impl keyword followed by the name of the struct that we declared on the storage part, and then we just implement, define the methods that we want and implement their code there. Okay. Events. Events are, for those who don't know what an event is they are signals that the smart contract emits when certain actions are performed, okay? So for example, if you are transferring a token, an NFT, a specific NFT from one user to another user, the smart contract emits an event saying that, okay, this NFT has been transferred from this address to that address, okay? So those are used, for example, by front ends, user interfaces that want to notify users when something happens in the blockchain, or I don't know, if a user wants to track what happens in a specific smart contract, he can just keep track of the events that are emitted there, okay? So the standard, the ERC-721 standard gives us some events that need to be emitted, and yeah, we're going to use them here. This is an example of an event. The standard, sorry, gives us this event signature, and this is how we add it to our Rust code. We just use the same signature inside the sol exclamation mark macro. Okay. Okay, so we are now going to see the specific methods that we need to implement. This QR code points to this repository where the actual code of the project that of the NFT actually exists. I'm going to try to be very explicit about the examples. I'm going to show like the code that we need to implement the methods and define the storage variables that we need. But if you want to follow along with the code, you can scan this QR code and just follow in that code, okay? So in that project, there's an SRC folder. Inside, you have two files. There's a lib.rs file and an ERC-721 file. Most of the functions that we're going to see are in the ERC-721 file because that's the actual implementation of the standard. And the lib file is just importing the interface to create the NFT, all right? You don't need to have it, but if you want to follow along, just scan it. All right, so what do we actually need to build our NFT? We need two properties, a name for our NFT and a symbol, and we need several methods. We need a transfer method, an approve, minting NFT, burning NFT, and a token URI, okay? So for the properties, yeah, we just need the name and the symbol. Name can be a full name of the token, for example, Stylus NFT, and the symbol will just an abbreviation of that token, SNFT, for example. And we are going to use these variables to store that information in the contract, right? So inside the public struct, we are going to just use a string name and a string called symbol, and that's it. We are going to store the variables there, okay? And the methods, in this case, we are assuming that the name and the symbol are hard-coded in the contract. So we are just going to create two getters for those variables, okay? So we just create one name function that just returns the name that we stored in the variable, and the symbol function that just returns the symbol that we stored in the storage variable. Okay, if we want to change that information after the contract is deployed, we will need setters for that. We're going to see examples of setters later, but for now, just the getters. All right, and now one of the main parts of the NFT, one of the most important parts, how to transfer the token. Okay. So the transfer function allows us to transfer functions, because there are several, allows us to transfer a token from one account to another. So when implementing this functionality, I always like to think, okay, what do I need to keep track of to give this functionality to the contract? And there are two things that I need to keep track of. What's the balance of each user? So how many tokens does a certain user has? And who owns what token at any given time, okay? So, yeah, and also the ERC 721 standard gives us these signatures for the functions. One transfer from function that just takes 3 inputs, from, a to, and a token ID. So this function, what it does, it just takes this token ID and transfers it from the from address to the to address. And two safe transfer from that actually do the same, but if the to address is a smart contract, it will execute a special function in that smart contract. Okay, we are not going to get into details about this, but just so you know that there are 3 transfer functions. The standard also gives us one event that needs to be emitted when transferring a token, and that's the event transfer that logs the 3 information that we need, the 3 pieces of information that we need: the from address, the to address, and the token ID. Okay. Now, let's go into Rust now. Let's go into our contract. So how do we store the information that we need to keep track of? We use 2 mappings for that. One mapping that we saw before, actually, the owner's mapping, that maps for each token ID who is the owner, and then a balance map. So for each address, how many tokens do they have? With these 2 mappings, we can keep track of everything that we need to keep track of. And for the methods, we are going to see the transfer from method, which is the first method that the standard tells us to implement. So for the transfer from, the standard tells us we need a from, a to, and a token ID. And in this case, we have divided the execution into 2 internal functions. The first one is require authorized to spend. And this is basically going to check if the user who is calling this function is authorized to transfer that token. So for example, if I have 1 token, well, another person shouldn't be able to transfer that token on my behalf, right? So we're going to take a look at this function in the next section when we talk about approving an NFT. But for now, just know that this checks if the user who is calling the function is authorized to send that token, okay? And then we call this internal transfer function that we're going to see now. So the transfer function takes the same 3 arguments, and what it does is that it's going to create a mutable variable for the owner of the token. So at first, the owner will be the current owner of the token that we want to transfer. So we did this little check here to verify that that actually that token has that NFT. And then we modify the owner to the destination address, all right? Then the next thing that we do is that we modify the balances of the from address and the to address, from the source address to the destination address. From the source address, we decrement 1 from their balance, and from the destination address, we increment in 1 their balance, okay? And finally, we emit the log that we need to emit. Okay, the safe transfer from functions, we are not going to see their details, but they basically do the same as transfer from, but call the function on ERC721 received on the destination address, in case those are smart contracts. All right, so second important part of an NFT, approve the management of an NFT. Okay, so these functions, what they do is that they grant another account the ability to manage one specific token ID or all the tokens owned by a specific account. Okay, so for example, if I have an NFT, I can give another person the ability to manage that token ID for me. And manage in this case means they can transfer that token from me. So why would I do that, for example? Well, if I'm using a platform where I can buy and sell NFTs, I probably want to give the ability to give that platform the ability to move my tokens so they can match buying and selling operations, right? And move those tokens on my behalf. So that's one example. For example, there are many others. So what do we need to keep track of in this case? We need to know what accounts have been granted rights over specific token IDs and what accounts have been granted rights over all tokens that are owned by specific accounts, okay? So these are the functions that the standard tells us that we need to implement. We have an approve method where we say, okay, for this address, I want to give this address the ability to manage this token ID that I own, obviously. And set approval for all is like, says something like, I want to give this address the ability to manage all my tokens. And I can enable that or disable that with the second parameter. So I can first enable the ability to move all my tokens or disable that later if I don't want to keep that on, okay? And then we have two getters for the same thing, for a specific token ID and for all the tokens of an owner. Also, the standard tells us to emit two events, one for when we grant allowance of a specific token with the event approval, and one when we grant allowance for all the tokens that I own, that is approval for all right? So, okay, let's move to Rust now. How do we keep track of that? What storage variables do we need? So we need two. We need one for the approvals of a specific token ID. So that's a map from token ID and who can transfer that token on my behalf. And we need a mapping, another mapping for addresses. I mean, this address is for all my tokens. I want to give the ability to move all my tokens to this address, okay? And I can enable or disable that. That's more or less what it says, right? So for the methods, we need one for approving, the approve method that we saw before. So we take the owner of the token ID. We verify that the user who is calling the function is either the owner or can manage the tokens of that owner. Remember that MSG sender, well, remember, I don't know if you know that, but MSG sender references the user who is calling the function. So MSG sender, if I'm calling the function, that will be my address, okay? So if my address is not the owner of the token, or the owner of the token hasn't granted me the ability to move their tokens, then I can't perform this operation. Okay, this throws an error. So if everything is okay, then a new entry is added to the approved mapping that we saw before, and a log is emitted. For the set approval for all, it's the same operation. Here, only the owner, only I can grant someone else the ability to move my tokens, okay? So I am the only one who can call this method, and well, not the only one, but when I call this method, it's going to create an entry for my address, okay? And also emit a log there. We have the getters here for the two mappings, get approved and is approved for all. I'm moving a bit too fast into these. These examples are all in the code, in the repository. So you can take a closer look later, but as we have short time here, I'm just moving fast through them, okay? And then the function that we left before without checking, which was require authorized to spend. Remember that when we want to transfer a token, we first check if the user who is calling the function is able to move that token, either because he's the owner of that token or he has been granted approval of moving that token. All right. So this is what this function does. So we first get who is the owner of the token, and we check obviously that the owner has that token. And then if the owner is the caller of the function, then we return okay. That means that they are authorized to spend. And we check in the approved for all mapping if the caller of the function is able to manage all the tokens of the owner of that token. Then we return okay. We say okay if you are approved to spend. And then we check the specific approved mapping to see if this specific token ID can be managed by the message sender, by the caller of the function, okay? And if none of these conditions are met, then we throw an error, meaning that the caller of the function is not allowed to transfer this token or to manage this token. Okay, so that's transfer and that's approval. For minting, I'm going to explain, just minting and with the scripts. So minting, in this case, there is no specific interface in the ERC 721 standard that tells us, okay, you have to create this function to mint, because it gives us the ability to say, okay, you can create all the tokens at the beginning when you deploy the contract or not, or you can have a function to mint the token and have it have the users pay some money to mint a token. But basically minting a token, what it's going to do is it's going to create a new token, okay? So for this functionality, we are going to create this function mint. We've added the payable keyword here, but for this example, it's going to be free to mint. And what we need to keep track of is how many tokens have been minted, and what a specific token is going to be created next, okay? And we're going to see why now. So for the storage, the only thing that we need is the total supply. We need to keep track of how many tokens have been minted. And this is also important because in this example, and this also happens in many NFTs, we are going to create the tokens incrementally. That means that when we deploy the contract, so no tokens are created, the first one that is going to be created is the token ID 0. Then the next one is going to be the 1, next one is going to be 2, next one is going to be 3, and so on and so forth. So for the method, we are just going to create this mint function. The token ID that we are going to create is actually the total supply. That means that, well, as I said before, when we deploy the contract, the total supply is 0. So the token ID that we're going to create is 0. When we create that one, the total supply is 1. So the next one is going to be the token ID 1, so on and so forth. So we get the token ID, and then we increment the total supply in 1. Okay, and then we call the transfer function that we saw before. to transfer that new token ID from the default address, I'll explain this now, to the MSG sender, who is the caller of the function. So why do we send that from the default address? Well, this is a particular behavior of blockchain, actually. That means that when we deploy the contract, we say that no tokens exist, but technically all tokens are owned by the zero address. So all tokens are owned by the zero address. So when we create a new token, we transfer that from the zero address to the caller of the function in this case. Okay. And yeah, and we also need two getters, which are the balance of, that gets a specific entry in the balance mapping that we saw at the beginning, and the owner of that, yeah, it does the same. It gets a specific entry of the owner's mapping that we saw at the beginning. I'm not going to explain burn an NFT because we don't have a lot of time, but basically it does the opposite of creating an NFT. It just removes a token without decrementing the total supply. It just sends the token to the default address, to the zero address. Okay. All right. Token URI. Let me briefly explain this. This is not actually part of the ERC-721 core standard. It's part of an extension of that standard. And what it does is that associate a specific URI to every token, so we can store specific information somewhere else. That can be on chain, off chain, whatever. So, and that information usually is, well, the name of that specific token, the description of that specific token, properties that that specific token has that might be different from other tokens, and yeah, several other information that we can save there. And and in this case, we can do like several different implementations of this, but one basic implementation will be just to return a root URL with the token ID .json file that will, yeah, that will return, well, the structure, the information of that specific token. Okay. All right. So before finishing, let me briefly talk about how to call these methods. And Chris already touched a bit into Foundry, sorry, that we can use Foundry to call these functions. And I wanted to show you an example here, because you saw that, I think I can show you an exact, yeah, I can show you an example here. If we go to the balance of, for example. So as you see here, so we declare this function, this balance of function, and as Chris mentioned, we use a snake case to call this function. But when we want to call this contract after it's been deployed, we are going to use a regular ABI like Solidity does, like we do with Solidity contracts. Okay. So if we go to, in this repo, also, this is the one that I'm sharing, there is a scripts folder to perform all these operations individually. Okay. So if we go to the get balance, we're going to call that same function using camel case as we see here. So this is because Stylus wants to, well, not Stylus actually, is to be able to guarantee to the user that they don't need to know the implementation details of any contract. We need to provide the same interface to access those contracts, regardless of the language they are written in. So if they are written in Solidity, they are accessed in this way. If they are written in Rust, they need to be accessed the same way. Okay, so that's why Stylus modifies, well, in this case, the SK modifies those snake case functions to be called using camel case or the standard way that we call smart contract functions. Okay, so this is just one example of Foundry that I think Chris wanted to touch a bit upon. We used cast call we pass here the RPC URL. This little variable that we have here is preloaded with the URL that we are using. In this case, can be your local node, can be Stylus testnet, for example. And then we pass the contract address that we want to call. This will be the contract where the contract is deployed. The address where the contract is deployed, and then the function that we want to call, the inputs that it receives, the outputs it returns, and well, in this case, you put the inputs of the call that you're going to make after the signature of the function. Okay. Jason, if you can tell me how much time I have left. If I don't have any more left, just tell me so. So if so, I can touch a bit on other things. But basically, yeah, that's a bit what I wanted to show you today. There are still a lot of things that could be explored here. In this QR code, it's the same one as before. This is the repo of the NFT contract that we just talked about. We have here several resources. I'm going to share this presentation as well with you. That's going to be inside the repo. And I think that's it. Yeah. Let me know, Jason, or anyone, if I still have some time left. If not, we can finish here. Okay, so while they respond, I'm going to show you something else. So in this repo, this is the repo that I'm sharing with you. This is the NFT contract. So we have several scripts, right? So you can add here several the variables that you want to use for this script. If you have used Bash before, or any terminal, this is usually the same with any shell. You can create here define the different variables that you want to use, and then you can call the different scripts that are inside this folder. So you can see what happens when you perform certain operation and what instruction you are using, what CLI command you are using for that specific instruction. Okay. So in this case, if we want to deploy our contract, for example, we will just call script deploy. Also, all these instructions that I'm sharing here are available in the README of the repo. Okay, so yeah, if you can read that from there as well. This deploy command, what it does is just it deploys. In this case, it deploys to the Stylus testnet, and it gives us the address of the contract that's been deployed. Right. So in this case, it is our NFT. So if we want to, for example, check the balance of our address, we can just call this command right here, and we see that the NFT balance is 0, and we can mint. We can call the mint. We can call the mint script to mint 1 token. This is sending the transaction to the blockchain now, to Stylus testnet. Right, perfect. If we check the balance now again, we have 1 NFT, and yeah, we can also transfer it to another account. We can get the token URI if we want. For example, this is prepare. These are all commands that I have prepared here to do operations with basic contract with predefined variables. For example, in this case, we are going to get the token URI of the token ID 0 here. We do that. We get that the token URI is this one. And yeah, I think that should be all. If you have any questions about Stylus, you can go to our Arbitrum Discord. There's a specific Stylus channel there. You can ask those questions there. I'll be sharing these. There's also a Telegram group. I think we have all of it here. This is specific for Arbitrum Stylus. There is another specific for FOSSASIA. Will be around there as well. And yeah, I think that's all. Yeah, Jason, I'm done. So thank you very much for being here, and yeah, hope you enjoy the rest of the day. Thank you.